I'm a big believer in don't build analytic models if you don't understand the decision that's going to be made with them. And don't say you can't build an analytic model because your data's no good unless you know how it's going to be used. And you can tell me that in the context of that decision, it would have to be this accurate, and I can't get that accuracy from this data. Then your data's no good. Then I believe you.
Yeah,
and your data's not good enough.
Yeah,
right?
not good enough today.
It's not good enough.
Exactly.
Today. Because I think this slows down a lot of analytics projects. There's this feeling that you have to be, everything has to be 95% accurate, and it's just like, well, many of our decisions are not even close to that.
No, right. In fact, I have a corollary for this experience, which is I say, if your business user says, I need the model to be 95% accurate, that's just a polite way of telling you to go away and not come back.
Hello, and welcome to another edition of the Decision Intelligence Lab. Along with my co-host, Michael Watson, I'm Vijay Mehrotra, and I'm very pleased to welcome our guest today, James Taylor, not the North Carolina ballad-singing 70s musician that many of us know and love, but rather James Taylor, who's an expert in the field of digital decisioning, the author of a book called Decisional Decisioning that's been very impactful for me, and currently executive partner at Blue Polaris, previously several years working in product at FICO, and prior to that, PeopleSoft, E&Y, and lots of other great places. We're looking forward to a great conversation with James today, and I want to throw it over to Mike to get us started.
Yeah, welcome, James. Let's kick it off right at the beginning. So, what originally drew you to this idea that you could analyze decisions systematically and they should become an asset of the organization?
So it was about, I don't know, something like 25, 20, maybe 30 years ago, because I'm old. And I was working in financial services, looking at financial services applications. And I was struck by the fact that we had a whole set of different applications that all used the same technology stack. So you had origination systems, and they used the technology stack. You had fraud detection systems, and they used the technology stack. And you had, collection systems and account management systems, and they all used the same technology stack. And they all worked the same way. They all use rules and advanced analytics and a certain amount of optimization and continuous improvement approaches, and they all applied those to a very, very specific decision. And they did that sort of independently of everything else they did. So they might have had a workflow or a case management environment, but it was somewhat separate. And it struck me that this was therefore a class of applications. This must be a class of applications. They must, because they're all using the same technology stack and they're all working the same way, but we talked about them as though they were all separate. Well, that's an origination system, and this is a fraud detection system. And I'm like, well, but this is so it's like saying they're all enterprise applications or they're all, ERP applications or whatever, right? Just because they do slightly different things, they all do it the same way. And so I started talking about this and saying, look, we need a name for this. We came up with this phrase, decision management. And started saying, look, this is about managing decisions. It's about automating and systematically getting control of these very high volume operational decisions. And you can apply that in originations and in customer management and all these other places, but they're a thing, and sort of that's where it all started.
Did that insight lead to were there economies of scale that you could exploit that because you recognized that these were decisions across all these systems? Like before, you had basically 6 different people doing decisions for fraud, decisions for accounts receivable, and then now you said, right. These are just decisions. Was there some economies of scale there?
I mean, to some extent. I mean, the companies involved in the space had many of them only did one of these things, but the ones like FICO and some of its direct competitors who did lots of these had started evolving a sort of platform strategy to make it easier to build them. They just hadn't really sort of pitched that to anybody, right? And so the sort of insight was to say, look, we can sell these individual tools, true, and we can sell the finished applications, also true, but we need some way to tie all this together into some kind of coherent strategy, and that means identifying this. And I think that was really the sort of gist of it. But the other thing is you get to learn how to do it, right? Because you realize you're all doing the same things. Then now the fraud team can learn from the originations team, and the originations team can learn from the account management team, and you get a certain amount of commonality of purpose and approach, right? And that led to first book and methodology and some other stuff that came out of that, because we realized there was a way to do this that was somewhat independent of the application you were particularly trying to build. And that really became important as the technology got cheap enough to use outside of retail credit.
Right. It's not that long ago that the cost of computing was a limiting factor. I think we've kind of, even us old people, have sort of forgotten that a bit.
No, absolutely, for sure. I mean, if you think about retail credit, take something like credit card fraud. right? You take the number of transactions multiplied by the potential risk of a transaction, and you can spend an enormous amount of money to prevent that, right? Because it's just worth a fortune, right? Well, that was okay because it cost you an enormous amount of money to build these applications. They were expensive, right? As the cost of the compute power has gone down, we've got better at the techniques. The cost of building them has changed, and now we see people building them for problems that are much less valuable individual decisions with much lower volumes, and it's still cost effective to build.
Oh, I want to ask you, James, just from kind of looking at the book, how would you distinguish the notion of simply automating tasks from truly kind of digital decision making and decision intelligence?
So that's an interesting question, right? And one of the things about a decision is that if you sort of lay out a process, or you lay out you think through a process, decisions are taken generally at a moment in time, right? And so thinking of them as somewhat orthogonal to the process is a very effective way to separate them. Because otherwise what happens is you sort of smear the decision making through the process like peanut butter, right? There's a little bit here and a little bit there and everything else, and you get this long drawn out process during which you make little bits of decisioning, and then if that one went okay, you go to the next bit. That goes okay, you go to the next bit. One of our prospective customers called it the plinko machine, right? You drop a thing in it, again goes ding 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 ding,
Yes.
and if it pops out of the other end, you do whatever it was you were thinking about. And this is terribly inefficient, right, from a conceptual point of view and from a technology point of view. So there's this sort of need to sort of gather up the decision making and say, the decision's a thing. It happens in the process, it happens at a moment in time. And if I think about it separately and I automate it independently, I create opportunities for reuse. I simplify my problem. I don't pave the cow path, because my decision making used to be made first. I did this, then I did this, then I did this other thing, and now we make that. There's no particular reason for that order, but it's sort of wired in to the way people make the decision. And so that's sort of, it is a task automation. If you're a process modeling type person, if you have a gateway in a process that relies on a complex decision, there ought to be a task right before that gateway that says make that decision, so that you can then go off down the right path, right? And so it is a task, right? But it's a very distinct kind of task. And thinking of it that way turns out to be one of those sort of really helpful things that just changes the way you approach the technology stack, changes the way you approach the design, all sorts of other things.
Just I'm kind of a little bit new to this field, so just so I can understand it, like your breakthrough here was that before when you ask someone how do they make a decision, they sort of dribble it out and say, well, I do this and this and this and this, and then get a decision. And you're trying to get them to focus on what's the exact, consolidate that on into one point in
Right.
time for this is the decision. And let's put all those other things, the information gathering or data inputs, those are not the decision. Is that the way that you can kind of get a breakthrough?
Yeah, I mean, that's part of it. I mean, a big part of it is that sort of that focus on the decision's a separate thing, right? You can, in fact, just automate the decision. And that says, here's the automation of this decision. I pick from one of the possible allowed answers, or values or whatever it might be, and I need a set of data to do that. And I can put that into a process or into a workflow or into a batch or into a user interface, whatever I want, right? But that's a distinct sort of unit of work that has distinct characteristics. And I think, take something like claims, medical claims. I was talking to a medical claims guy the other day, and he was describing how they made how they processed their claims. And they had dozens and dozens of tasks in this process that did all sorts of different things. Well, I got to check for eligibility, then I know the state you're in and what plan you're in, and does the plan cover this kind of claim? And there's all these tasks. And I'm like, guys, you got to assemble the data for the claim, decide if you're going to pay the claim, and then pay the claim. And you have hundreds of steps to do this. Why? You've created this monstrously complex process because you didn't identify the decision as a step. And had you identified the decision as a step, you would have a much simpler process, because it would basically have a bunch of stuff to gather up the data for a claim. Then it would decide if we were going to pay the claim, and if so, how much. And then it would act on the decision, send you a rejection notice, or say yes and send you a pay the bill, or whatever it might be, right? And so
that's awesome. So basically, it's like you just had the decision is just do you pay the claim or not, and it's like the real world is so complicated. It's hard for people to understand that was the decision.
Yes.
So it's kind of interesting as I was listening to you guys. It feels like what we're talking about digital decisioning is essentially a policy that we take inputs, some of which are upstream, raw data, some of which are predictions, what have you. But those inputs then give us a policy decision based on those values we will do or not do this.
Yeah, I mean, I probably wouldn't use the word policy only because some of the requirements are policy driven, but not all of them. Right? Often you have this sort of concentric layers where you've got a sort of regulatory framework which you must stay inside, a policy framework that you'll probably stay inside, and then within that, often sort of business expertise or analytically driven choices within the available options, right? And often you see these things put into lumps, right? I talk to a lot of machine learning folks, even very experienced ones, and they're like, well, why can't I just feed the machine learning into your decision? Then you can make decisions with it. I'll decide what I think you should do analytically, and then you can just decide if I need to be overridden. And I'm like, well, that works for certain kinds of analytic problems, but a more general purpose framework says there's a whole decision within which there are a number of useful predictions, which up to and including the whole answer, right? But more often, part of the answer. And if you think of it that way, then instead of, how much Python code have you guys seen, which is really just rules being written into the model so that the model doesn't do certain things in certain circumstances. And I'm like, I think that's a terrible idea. I think the machine learning model should only contain things that are data driven. If the data doesn't tell you it, don't put it in the model. Wrap the model with it. That way the model stays essentially reflective of the data, and the rest of the decision stays reflective of the constraints on the data. And that to me has always been an easier management problem and an easier continuous improvement problem.
Yeah, so good correction. I've used the term in the sense that I've used the term policy in the Warren Powell sense, and not
Yes,
it has
sure.
a more specific kind of implication there. But yeah, excellent. So all this makes sense, and having taught from your digital decisioning book, I sort of understand the value of decision maps. I'm interested in who gets it and what kind of companies successfully manage to implement these things into their workflow, and who are the ones that don't, and what sort of differentiates them.
That's an interesting question. So there are more of these decisions in financial services and insurance and sort of insurance-related problems because they have more problems that meet the math criteria, right? I mean, there's a number of decisions times value of decision equals the amount you have to get, the potential return on your investment, right? But we have seen these systems work in basically every environment out there, right? If there's enough volume in a decision or enough value in consistency, because we've done some very low volume ones where it was not about the volume or the speed, it was about the consistency of decision making, not wanting to have any variability. And really, any industry can do it. I would say there's a slightly lower success rate in industrial manufacturing because they're all a bit process oriented. We've had a certain mixed bag in places that are very into Six Sigma and sort of green belts and black belts because they tend to think everything's a process. Though GE Finance did do famously a lot of work with decisioning and applied Six Sigma, but they applied Six Sigma just to the decision and separately to the process the decision was part of, right? So, the focus on process and an unwillingness to see a decision as a separate thing is probably the biggest hurdle. And then there's a whole set that paralyze themselves by saying our data's no good. And say, because my data is no good, I can't possibly automate this decision. Therefore, I won't try, which is another terrible idea.
What do companies do in that situation if they think that their data is terrible? Let's say it might be bad.
Right.
What would you recommend?
We have a mantra, which Vijay will know from the book. We say decision first. So first thing you have to do is define how you make the decision, and that will tell you what data you need and how you use the data, and therefore how accurate the data has to be. This is true of analytics also. And then you may determine that, yes, you don't have enough data or you don't have the right data, but you will know which part of the decision you can't make from your data, which bits you can make from your data. And often there is more there and more potential there than people think there is, right? Because although their data is in fact bad, it's not, to some extent, it can't be so bad you can't make the decision because you're already making the decision.
That's what I was going to ask.
So it's like
this
you
is
must
what we
be
ran
making
into.
this decision already,
Right? Yeah. So how do you show that? Is that you say like, look, here's how you're currently making the decision with this data, and it's got this amount of variability. And if you just add this one little piece of data, you're going to get 5% better. It's not perfect, but it's 5% better than what you're currently doing. Is that how you talk about it?
Pretty much, right? I mean, I like to tell a story in an analytic context, right? Because this comes up most often in the context of predictive analytics, machine learning, right? When people say, my data is no good to build a prediction. So we were doing a disability claims project, and they spent years doing process improvements on this process, right? And we came in and said, well, there's a decision here. Should we fast track this disability claim? So fast tracking means instead of sending a nurse to visit you, they'll just do a phone interview and everything else. Big cost saving, big time saving. It's very important, but obviously not as good at detecting problems. So anyway, so we laid out this decision. There were certain kinds of disability claims they never fast tracked, like mental health ones and bad backs and some other things. And they didn't fast track claims if they'd already paid a claim for you. And there was a bunch of like decision rules essentially that built this up. And then we said, okay, so what kind of analytic would help? And they're like, well, we also get these medical reports. And it would be great if we knew whether the medical report backed up the thing you're claiming for. And the analytics team was all super excited because they were like, that's great. We were going to do that analysis. And then they said, wait, you phrased it a certain way. You didn't say it would be great if you knew what was described in the medical report. You just want to know if it matches the claim. And they're like, yeah, claim's got certain ICD-10 codes in it. We want to know if those are supported by the medical report or not. I don't care what else is wrong with you, really, fundamentally. And they're like, oh, well, that would be easier than what we were going to do, which was give you a list of all the ICD-10 codes that were implied by the medical report. And they said, okay, so that's good. That's better. And then we said, okay, in the context of this decision, which we've got well defined, how accurate would this model have to be? And the business user said, better than 50-50. And the analytics team basically fell off their chairs, didn't really believe her. In fact, they made her repeat it and recorded her saying it because they were convinced she would come back to them and say, this model's not accurate enough, right? Because that's been their experience. But she explained, in the context of this decision, where I have a fallback position if it turns out we're wrong, and where we've already eliminated all the most problematic ones that we never fast track, I just need a sniff test. That's all we're going to do by hand. We're just going to flick through it. Does it seem like it matches the claim? Yeah, it does. Great. Off it goes, right? And so the analytics team, and I remember talking to them afterwards, and I'm like, so how long would it take? You had a plan to do this detailed analysis to a 95% accuracy or something, right, of all the ICD-10 codes, and it was like an 18-month project, right? And I said, how long is it going to take you to do what she wants? 60 days? 75? And I'm like, okay, so that's 15 months you just saved. Right. It would have been completely wasted effort because the analytic didn't need to be that accurate in the context of this decision. So I'm a big believer in like, don't build analytic models if you don't understand the decision that's going to be made with them. And don't say you can't build an analytic model because your data's no good unless you know how it's going to be used. And you can tell me that in the context of that decision, it would have to be this accurate, and I can't get that accuracy from this data. Then your data's no good. Then I believe you.
Yeah. And your data's not good enough.
Yeah, not good enough today.
Not good enough
today.
Because I think this slows down a lot of analytics projects. There's this feeling that you have to be, everything has to be 95% accurate, and it's just like, well, many of our decisions are not even close to that.
No, right. In fact, I have a corollary for this experience, which is I say, if your business user says, I need this model to be, when you ask them, I need the model to be 95% accurate, that's just a polite way of telling you to go away and not come back. It means they've got no interest in using your model, and they're trying to set a bar high enough that you'll go away and won't come back. Because they don't really think you understand their problem. Or they think that your analytics not going to help them with their problem. And they don't want to deal with you anymore. Because in all the years we've done it the other way around, no one's ever said 95% or even 90%. Right?
So, and is this because very often the people coming in are either from the IT organization or from a third party that has been foisted upon the business user, and they're kind of looking for reasons to get them to go away because they don't think they're, we're here from the government, we're here to help, sort of thing?
Sometimes, but it happens with internal data science teams too, because the data scientists come in and tell them things. Right? And my experience is that when data scientists do all their analysis without talking to the business first, and then go present stuff to the business, one of two things generally happen. One is they tell things the business already knew. Right? Yes, we obviously knew that, right? The fact that we've never written it down, it's a blinding flash of the obvious because we've all got 30 years experience. We've been running the firm a long time. Of course we knew that, right? Or it's something that's manifestly untrue because it just reflects what the data says. And what data says is not what reality says. And both of these essentially immediately undermine the data science team.
Yes.
Because they're like, okay, so you're just a bunch of propeller heads, got no common sense at all. Okay, fine, right? so I'm done now. Yeah, I have everything I need to know how I'm going to behave.
Let's say we're going to automate a decision. We've declared, okay, this is a decision. We know this is a thing, and there's still some uncertainty in the decision. or and that's a key aspect of it. Or there's some multi-objective part where there's a couple objectives that you're balancing, and it's not always clear cut like what you're going to do. Like how do you think about automating those kind of decisions, or
Right.
or am I overthinking it?
No, you're not. It's absolutely the key problem. I mean, one of the things when I started was we could encourage people to think about the decision, but we didn't have good techniques to do it, right? So you would still write requirements documents or agile stories or whatever, but just trying to be focused on the decision. And then a little bit more than a decade ago, this idea of what's called decision requirements diagrams that became the heart of decision modeling came into being. And it's really a functional decomposition technique that lets you break down a decision into its component pieces, build a dependency network. And it turns out to be incredibly effective at describing how decisions work. And I remember the first time I read about it, a friend had written a book and sent me a draft because he wanted me to write it forward. And I'm like, that's it. We're going to use this. And we've used it literally on every project since, right? We started building software for it the minute I got off the phone. I mean, it was obviously the right thing to do, right? And that enables you to break the problem down. And you can say that this decision is driven by this regulation, this decision is driven by these policies. This one, I don't really know how we make that, but I have to find out. This one really needs to deal with this uncertainty. And you can break the problem down into a whole series of small pieces, right? And different technologies work for different pieces. And this has proven to be just as true now. We've got AI components and large language models and foundation models as it was when we only had rules and predictive analytics and data mining, right? So it's this X of breaking it down, right? And then when you're doing that, sometimes you find there are decisions in there where realistically, there's still only a human decision. It's still the only possibility. But what you've done is instead of saying there's this big decision, and the only way to make this big decision is with a human, now you've got this much smaller decision that still requires a human. So the analogy I use for that is like commercial building insurance. So let's say I'm trying to write commercial insurance for your office.
Yeah.
And there's a whole bunch of data that I have from the application form that I can look up from the city. I can look up the plans. I can get all this data, but it won't tell me how good your fire escapes are, right? Because that's just not something it does, right? So I can't automate that decision, not completely. But what I could do is I could automate the decision and say, okay, I need someone to decide if the fire escapes are appropriate for the purpose of the building. I don't have the data. So I'm going to dispatch someone to go do that. And they go do that when they come back. But they don't have to underwrite. I'm not sending them to underwrite the building. I'm sending them to inspect it and look for this.
Okay,
problem.
gotcha.
They come back and say, yeah, the fire escapes are okay. They're not great. As long as there weren't more than N people in the building, they would be fine, right? That then gets submitted back to the decision engine, which now has an answer to that question and can, in fact, calculate the policy costs and everything else, because the rest of it was all very data-driven. And so what we found is, and this sort of leads into the decision augmentation discussion, right, is that you have to aim for automation. You have to try and automate the decision, see which bits you can't automate, and then apply analytics, apply optimization, or apply humans to those bits where there isn't a deterministic way of figuring it out. And that tends to work much better.
Let me drill down on that as well, because I've actually heard you say this to me before, and it's always intriguing, and I think it'll be of interest to the audience, right? Which is the case that you're making for automate first is essentially that if you don't try to do that, you'll never do it. You'll never get there. Can you say more about why that's your default mindset?
Yeah, so that's part of it, right? So the basic premise here is, if you think about the spectrum, right, and like Gartner lays this out, other people do, where you've got decision support, decision augmentation, and decision automation. There's the sort of like three big buckets. And everyone thinks, I start off with decision support, and then I gradually work my way up through more and more support till I get into augmentation, and then ultimately I'll eventually be able to automate it completely. And our experience is that it doesn't work that way. Because what happens is people are too flexible. And so your decision support environment just becomes a more and more sophisticated and a complicated decision support environment. And you never really make it any further because you're still assuming that the whole decision is the unit of work. Right? And whole decisions, approving claims, flagging credit card transactions as potentially money laundering, that kind of thing is a complicated decision, right? By and large, there's lots of moving parts. And so what we found is you have to aim to try to automate as much of it as you can, which makes you think through what are all the pieces, which ones can I in fact define sufficiently precisely that I can automate it, and then only going through that exercise reveals the ones that you really can't do, right? And then you can say, okay, do I have another tech AI, generative AI, machine learning, optimization that can solve this problem for me. Yes, okay, great, I'll do that. And if I still can't do it, then I'm going to have a human do it. But I have no idea before I start that journey if that decision is going to be the top of the decision pyramid, if you like, or the bottom. Everyone assumes when they do augmentation that the engine will do all this work at the bottom, and then the big human, will make the decision at the end, right? And our experience often is the last decision is actually the easiest bit because you've done all the hard work, and the final bit's essentially a derivative of that, right? So it's much more common for some of the lower level input decisions to be genuinely hard to do with a computer. Either you have to go somewhere or look at something or make some assessment of someone's believability or something like that. But once you've done that, the rest of it follows,
So I think something that I heard you say there was that if we don't kind of go through the rigor of examining decision for purposes of, essentially for purposes of cutting the human out of the loop, we leave the sloppiness of the human thinking.
Yeah.
And we kind of allow for TBD, kick the can down the road, we'll make that call in the moment type of thing. And only if we're truly trying to break it down in such a way that we're willing to scale it, do we find the spots that we're not willing to scale.
Exactly. Yes. I mean, if I was to say, okay, Mike, let's say, you got to make a decision as to, I don't know, the grade on a paper. Can we automate that? You'd say no, right? Okay.
Right.
And I'd be like, okay, so how do you make the decision about the grade on the paper, Mike? And I would make you break it down into pieces, right? And then I guarantee you some of those bits I could in fact automate.
Right.
Was it submitted on time? Does it look like it's fraudulent? Does it look like other papers? Has it been downloaded from the web?
Yeah.
There's a bunch of things I probably could do.
Right.
And I probably can't make it, and I can probably assess how well written it is, whether it's how it scores on some of these language assessments, all these things I could do for you. I just can't tell you whether it makes any sense necessarily, given the setting necessarily, right? I might be able to, but there's some decisions in there that you still have to make because it's your class and you're teaching these students, right?
Right.
But not all of it.
I liked your example about the fire escape too, because it seems like when you build this process, I know you talk about this in other places. Is now you have a way to audit this. It's like you have this. There's a million complicated things that go in. If I was just coming up with the price, I just come up with the price, and I had all these factors in my head. But now you've automated everything except the fire escape, and someone's got their name next to that that says fire escape is okay-ish.
Yeah,
and I know what okay-ish means 50%, and 50% feeds in this model, and that gives me a 10% boost in the cost, and then. It's
auditable. Exactly. Yeah, it's very auditable, right? There's a great book, one of Kahneman's book called Noise. I think it was called Noise, but it was about noise. And they did these noise audits in companies. They say, well, how much variation do you think you have? And consistently companies would say 15%, 10%, some variation like the price of an underwritten policy. And the audit would discover it was closer to 50%. And they come back and say, and they would be like, it's 15%. We're okay with that level of variation. It's important to have the personal relationship. Okay, great. All right. Now we come back and say, actually, Mike is going to charge James half as much again as Vijay is going to charge James. You still okay? And they're like, no, not really. That's much too high, right? And and as you say, it doesn't mean that there isn't room for variation in there. It just means that if you just let it be at the whole thing, then you get a lot more variation than perhaps you're expecting.
Right.
And obviously for some things like auto claims and some of these other things, you don't want any variation at all, right?
It's interesting because when you think of FICO, and somehow, James, when I think of you, I always think financial services. Where are you seeing the most kind of interesting and novel and impactful applications outside of the financial services space these last few years?
That's interesting. So we have some very interesting projects going on in healthcare. And it's in the US, right? So it's healthcare payers, because unlike a nationalized or government-run sort of medical delivery system, it's not really the delivery bits of the healthcare system that think of you as a patient, a whole person, right? They think of you as the MRI place thinks of you as people who come get MRIs, and the internal medicine people think of you as the internal medicine person, right? But the payers have all this data about all the things you're doing, right? And a number of them are really trying to improve your healthcare outcomes, right? While also reducing your cost. Don't get me wrong. It's not purely altruistic on their part, right?
Right.
They want you to be healthier and cheaper because that's better for them, right? And so they're starting to really pull together multiple machine learning models that predict different things, different risks about you, a whole bunch of data about where you live and what plan you're on and what what their network looks like in those states and everything else, and try and recommend things to you to generate this very, very personalized care plan. And it's sort of like next best action, but applied to care plans, right? And I think this whole area of next best action is one of those areas that was starting to develop and got completely hijacked by machine learning, where a whole bunch of people said, I don't need to do anything else except pile up the data and let it predict what Mike's going to buy next or what offer to make Mike, right? And I'm done.
Yeah.
And I think we missed an opportunity to carry on the trajectory and sort of enhance it with machine learning. And we've tried to throw the baby out with the bathwater. So I do begin to see in healthcare and insurance and some other places, this sense of, actually, this very sort of commercial oriented engine for making recommendations is not really getting it done for me, right? I mean, I remember years ago talking to a telco about this in Australia, if I remember correctly, and their observation was sometimes, let's say you've got 3 lines. The most useful thing for me to know is how old are the people using the other 2 lines? Because are they teenagers or kids or other adults or anything else? And I don't need to know that. You don't need to tell me that when you open the account. You just buy 3 lines. But I'd really like to know who's using the other lines because that tells me a lot. So, the next best action is, in fact, to ask you how old this thing. Not trying to sell you anything, right? Because knowing that will help me sell you things later, right? And the analytics are very rarely going to come up with that, right? They're just going to say best offer is, cricket scores or whatever it might be, right? And so I think that this approach, this sort of multi-technology sort of enriched view of the world is particularly effective with these kind of next best action systems. So I think that's a really interesting area, right? I think that we're seeing some interesting projects there and so on. And then I think the other thing is around is applying some of this stuff to documents rather than to data. So I was talking to a commercial insurance company, and we built an insurance engine for them, an underwriting engine, using this approach. And one of the interesting things was they're like, yeah, but our underwriting system doesn't have all this data in it. And we're like, no, but people have probably got competitive quotes or existing policies, and those have all the data in. And now AI is really good at reading documents, right? So we can sort of just say, well, upload the document. I will I will see if I can decide with what's in the document. And then I'll tell you how far I got. And so I think there's some really interesting, technological areas. If a document is enough information to decide against, does that change when you make decisions? And I think it does. And then secondly, there's this sort of, this focused on really being customer centric, which we sort of, outsourced to the data science team for a while. And I think it's beginning to come back a little bit and say, actually, there's more to it than that. We've got people and case managers and call centers and medical teams or experts in one kind or another, and they have opinions and points of view that would be useful to include in all of this. So
I have a different type of question for you. This is about your business. So, I think some people will be interested to know, what made you start and do this on your own, like branch out and do this on your own. And second, why did you decide to partner so tightly with IBM? I think partner business is interesting, and not everyone thinks about it. So I'd be curious to hear your answers to those questions.
Yeah. So the company started back in 2009, right? So I'd recently, gone independent, and I wanted to have a vehicle to advise other software companies. So the initial premise was that I got a lot of feedback from other companies that they liked the approach, but couldn't use it when I worked for one of the vendors. So as soon as I went independent, they were like, great, now we can all do it. So if you notice, all the business rules products changed their name to have decision in. And so I worked with it was great. I could work with this enormous range of vendors. But after a while, I realized that I really wanted to build things. I'd been in software development, been a product manager, and then I'd been in marketing and this sort of analyst work for a long time. And I wanted to get back into building systems again. So we started really focusing on end user customers who wanted to use these technologies to solve the problem. So that became a more and more dominant piece of decision management solutions business. And then I was joined by my now partner, Ryan, and he brought a much more focused effort to that. So we started to build our consulting business to really deliver systems. And then a couple of years ago, we realized that AI was starting to change the conversation. And in particular, there were people who were foolish enough to think AI was an alternative to decision management, not a complement to it. And so the name was starting to get in the way a little bit. We also had an opportunity to add some other lines of business around process and workflow, around infrastructure and managed services that were rather outside of our traditional sort of, our original scope. So we sort of rebranded as Blue Polaris to give ourselves a little bit more, frankly, flexibility as to what kind of services we offered, right? We're still very focused on defining the problem first, using a lot of modeling notation, really trying to define that and then mix and match the right set of technologies and everything else. So that was the sort of the company journey. And we're an IBM business partner. I mean, if you look at there's a couple of reasons. First of all, that they actively want to partner, and you'd be amazed how many software companies don't, or who say they do, but are just really, really bad at it. I won't name names, but there are some who are just terrible at it, right? They compete with you, they undercut you, they lie about you. I mean, it just is awful, right? And IBM doesn't do that, right? So we have a good relationship with the IBM teams, and they have really good products in all the categories we care about, right? They have a great machine learning platform, but they're very comfortable with other customers using their own machine learning platform. They have a great data platform, but again, they have lots of customers using Snowflake or Databricks or something else. They've got great set of decision engines, all the major market leaders, and so it's very easy to partner with them because they've got a technology stack that works, and they're much more comfortable with customers mixing and matching. There's some other companies out there that have a whole stack from our point of view that do all the things we care about, but they tend to be much more focused on, no, you've got to be on our platform and use all our stuff. And that's just not realistic for most big companies, right? I mean, even if it is realistic, they're grumpy about it. And so we like the fact that I just went through this right now. We're just talking about modernizing a decision platform for a big financial services institution. And there were some questions in there about modernizing machine learning and going from essentially turning machine learning models into rules and loading them into a rules execution environment versus calling them as deployed machine learning models. And we're like, you should absolutely do that. If you need a platform to do that, there's an IBM one you can buy. But if you already have one and you're just not using it to deploy the models, that's fine too. Just deploy the models and we'll call them there. And so that flexibility to be able to say, if you need it, we can sell it to you. And if you don't need it, we can work with it, is really important to us, right? We're big believers in mixing and matching technology. And, it's nice to have that ability.
And it keeps you independent as a independent company. You're still independent. IBM's your partner, but if you can work with other things. And if IBM tried to lock you in, it would limit your ability to grow your own business.
Right. Yeah. And I would also say that recently, both on the machine learning front and the AI front, their attitude to models is far better than many, right? They say it's your data, customer, and if you build a model from it, it's your model. Right? The Granite models, Dockling, these foundation models that you can tune and build on, the attitude of the machine learning models, this unwilling, IBM's clearly not trying to suck your data in so it can build master models the way a lot of the ERP and CRM platforms are. And I think that's a more honest and a very direct approach for these big, and we're mostly working with large companies, right? They have a lot of insight, a lot of data, and that appeals to them. We had at least one customer who were like, I won't name names. There's all this AI capability in this enterprise application platform, cloud-based application platform that we use, but I don't want to use it. Because if I use it, then everything I know is in their platform. All my customer data, all my data, and all the insights I've ever built from that data. No. I want to be able to get the data out, put it in my own environment, build my own data models, and put my own models back into the environment. Because I want to own that IP. And I think that's a lot easier with IBM Stack. So we like that too. We're very, that matches our mindset and the mindset of our customers.
That's perfect. What a good business fit. All right, Vijay, you want to wrap it up?
Yeah. Last question, James. If you had one or two pieces of advice for aspiring executive, we'll call him a director at a company, wanted to make his mark by improving decision making in his organization, what are your one or two pieces of closing advice for that person?
Yeah, no problem. So we have a sort of we typically say, I've been saying for years, and we like to tell people that there are three really important things. The first thing is you have to begin with the decision in mind. You have to think about the decision and put the decision first. Understand it, scope it, build a model of it. Really understand, because you can't do anything effectively until you've done that. The second thing is what you'll realize once you've done that is that you're going to have to mix and match technologies. There is no one technology that's going to solve most decision-making problems. So you've got to be thinking in terms of, given that definition of the decision, what's the right mix of technologies? So that's the second thing. Always think about mixing and matching technologies. And the third thing is that it's a continuous improvement exercise. Decision-making systems, in our experience, across the company, we have like 100 years of experience with doing this, right? Is that they always change. The market changes, regulations change, policies change, there are court rulings, competitors change their behavior. And so what a good decision looks like is not a static thing. And so building it for transparency and agility and for continuous improvement is essential, right? And so you've got to build that in at the beginning, right? IT departments have a terrible habit of like building version 1 and say, we'll add that to version 2. And our experience is it goes in version 1 or it goes in version never. You have to begin with a decision in mind. You have to think about decisions first. You have to mix and match technology, and you have to think right from the beginning about how you are going to continuously improve it. And those 3 things are the sort of the key to long-term success.
All right, that's a perfect way to wrap up, James. Appreciate your time, and thanks for joining us on our podcast.
It was a delight. Thanks very much.
And thanks to you listeners for joining us once again. If you haven't subscribed yet, go to our Substack page, Decision Intelligence Lab, on the Substack platform to subscribe, and we'll see you back here again soon.